We're gonna do a little video to demonstrate the tasks of Laboratory 5, the instructions of Lab 5, and I'm putting that into my downloads. Also, a file of simple problem domains. So if we go to downloads, here's Lab 5. And the first part that you see here is to actually run LabCat, but now a series of problems we will define ourselves. You should have had LabCat already installed. We're basically doing task planning using PDDL. We're going to go into here, but I'm going to do everything basically from scratch here. So LabCat is here. I'm going to unzip it. In here, remember I have to do sconce. And as a result of that, I have this library here. You need to go to external. This is a repetition workshop 4. And here I do a make the append. And then I do make live ff. Let's check what I have here. We have it there. Now I could copy it, but I already have in user live. That's because in this same machine I had done these steps before. Go into LabCat, this particular planner. If we look at the top of LabCat, we see that we have a folder called planners. Type sconce again. And this will be a planner that allows us to read domains and then different instances of those domains. So here's the executable. There are some examples. There's examples from the 21 competition. I'm going to go into downloads, LabCat master. We go into benchmarks, and in benchmarks there's these ones, for example. There's Blocks World. Try one of those. The path may be slightly different. This is path. We go to the place where I have my planner. Minus domain. Put the path. In Blocks World, the domain is called domain PDDL. Go where I have the planner. You can see here in the instructions, we say the instance by the problem command line option. So problem. I'm going to copy the path from here. Instances. And in your instructions, they ask you to do, for example, blocks PS001 PDDL. Blocks 001 PDDL and fire the planner. You actually get the plan. First time it picks up object D, then extracts D into C, and so on. You can explore what the instance is and what the domain is. I'm going to use a third tab to go into downloads. We have the simple navigation.tar. There's a domain specification and there's some instances. I'm going to invoke the same planner, but now providing these parameters in the command line. Let's go to the second tab where the planner is. There is the planner, domain, navigation domain, problem. Put the path again. Let's try instance 1. And you run it. Here you have the new plan, which says moves from B1 to B2, then I have from T2 to 3, 3, 4, 4 to 8, 8 to 12, 12 to 16, and that reaches the goal. Your job is, besides running all these examples, to make drawings about what this really means, what is the domain, and what are the particular instances. You can run instance 2 and check the plan. It's a bit different. Run instance 3, check the plan that came as a result of that. Run instance 4. There's a plan, explain the plan. You have to explain what was the challenge that the planner solved in each of those cases. That's part of your submission. Here are the instructions of Lab 5, and we're going to focus on this part on a fresh installation of Webots. Here it takes you to the website of Webots, and you can see a way to download it. I'm not going to install it this way. Close this, and I'm going to install it with instructions of their APT procedure. So we're basically going to follow these steps. I'm going to do this one first. I have summarized these steps in here, but follow the ones on the website. They may be a bit more accurate. So we're going back to the next one is the one about the registry. It's usually good to check how much free space we have, because these virtual machines that we build to distribute for the US, they are very small in hard drive. So there's some recommendations here about how to clean up space. So we have 43%. I'm going to do the update again. Then we do install Webots this way. It doesn't matter that you get these warnings. Try to open worlds here. There is some samples, demos, worlds, hexapod. Simulation is running, so we're going to stop it here. Remind you that it's important that your Webots home is set up. You can type, which Webots, you can see that the path is user local. Take away the win and Webots, and that's so. And you do that by saying export your variable, not the value, equals. And remember that this is only valid in the current terminal. So if I say this here, I get this value, but if I go to the second one, I don't get that value. Webots and start Webots. This is a very powerful simulator similar to Gazebo for all sorts of robots. Be patient, it takes a little bit to start. Webots remembers the last world. There's a soccer demo. Let's try that one. And you see some robots. Remember, Webots starts running, so if it's consuming too many resources for you, stop it or pause it here. Just let's type quit, and Webots it's over. So now, if you look at your instructions here, there is something about how do we make Webots work with ROS. In the tutorials here, you can go to tutorials 8 using ROS. You can go to Webots ROS package, and this is in GitHub. You may need to sign up for downloading this, but I have also made it available in the lab. And I'm downloading here the Webots ROS.tar. So I'm saving that into the downloads. start by making a Catkin workspace Webots from. I'm gonna go there. Not this one. Catkin workspace Webots. Make a directory source. Catkin make. While that's going on, let's go here to downloads and examine what does the Webots package have. It is a package already. Here it is compiled fine because there was nothing. Go into source. There's no packages, so the first one will be in downloads Webots ROS. Go up one level. Compile this. Okay, we finished compiling. We're gonna use ROS core. Remember that every time you compile in an environment, you should complete the setup bash. We will run the example that comes here for the epoch. So before I do that, remember I need to have my Webots home variable set up. I don't have it here, so which Webots, and so now let's file Webots. Remember to stop Webots, open a new world, languages, so projects, languages, ROS, worlds, epoch line. Okay, once the world is loaded, let me stop the simulation. Nobody's controlling the robot, so we're gonna stop that. We're gonna go back to this terminal, and here is when I'm gonna fire the simulation. And as it runs, if I go back to see what's going on with Webots, our robot starts to walk around. It's a very slow simulation, so be very patient. We're gonna do now this with logic label final statement. Reset the simulation. I'm gonna stop ROS core here. This is because the simulation before steps out of the line. Sometimes, remember, ROS is a bit difficult. Kill the running of the, and we have our screen back. Download the machine and its wrapper, so that is in the lab. Choose this one and we save it into downloads, and that's the wrapper for the machine to recognize the dark line, and this is the machine itself. Remember this guy is the same we're gonna need, so if you don't remember, we're gonna use the mypal CLFSM download CLFSM simulator. Maybe we do that first. Tar extract with file without a minus because it's a BZ. Now we have a Catkin workspace with a source with the three things from the very early times of the very first machines. I'm going to go into source. The only package I have at the moment, I have that one, but I'm going to start to move from downloads, Catkin workspace, source, the scheduler of final state machines. Repeat that for its library. So we are not using the whiteboard, which is a different type of middleware for robotics communication, but CLFSM needs it. Compile them. All right, the other element we need to check is the epoch sensor wrapper. This guy here. we see that it's a package. Move it from where I extracted it. Webots model wrapper and put it here. One at a time, building my workspace. And now the machine that follows a line. The machine is a package, as we see here, or you can actually list it to see that it includes a machine, etc. We're going to source. I'm going to move from downloads, epoch machine. Now, in order to compile the machine, let's just go inside it, and it has a folder machine. Run the script on it. Compile the machine. The things that we need to do, let's just make sure the bell setup dash. Run the wrapper. This is kind of running the sensors. Webots would run here. The third window, we go into the bell lib, copy the compile machine into epoch machine, Linux. We take away the lib part. We are ready to run this guy. The window here where we run ROS core. This is the window where we run Webots. Delete this guy's. Stop the simulation. Out here, and then run the machine. Start the simulation here. Go back here. The robot is moving. The sensor is reporting information. And be patient that the will go around.